Hello everybody. In this lesson we are going to study about solving a pair of linear equations in two variables by the method of elimination. We have already studied how to solve a pair of linear equations by graphical method, and we have also studied how to solve a pair of linear equations by the method of substitution. Now we will study solving a pair of linear equations by the method of elimination. Welcome to the lesson. Let's try this. Solve the following pair of linear equations by the elimination method. X plus y is equal to 5, 2x minus 3y equal to 4. Let us represent these equations as equation 1 and equation 2. Now in the elimination method, the process is as follows. First step, choose any one of the variables to be eliminated. Either you can choose x to eliminate it, or you can choose y to be eliminated. So let us say we choose y to eliminate it. Now if we have to eliminate y, then the coefficients of y in both the equations have to be the same and their signs must be opposite. Now let's look at the coefficients of y. Over here we have minus 3 and over here it's plus 1. The signs are opposite but the coefficients are not the same. So in order to eliminate y, we must make the coefficients same. So if this is 3y, then we have to make this also as 3y. How do we do that? We will multiply the whole equation, the first equation, by 3. Now let's see what happens. When we do that, our first equation becomes 3 times x, 3x, plus 3 times y, 3y, equal to 5 times 3, 15. Our second equation remains the same, 2x minus 3y equal to 4. Now we will add the two equations. So plus 3x minus 3y cancels with each other. 3x plus 2x is going to become 5x equal to 15 plus 4 is 19. Then x is going to be equal to 19 over 5. So we know the value of x now. Once we know the value of x, we will take the value of x and plug it into any one of the equations, either 1 or 2, whichever is easy for us to solve. So let us pick up equation 1. So x plus y is equal to 5. We already know what x is, 19 over 5. So we can substitute 19 over 5 plus y equal to 5. Y is equal to 5 minus 19 over 5. We know how to subtract two fractions. So 5 minus 19 over 5 is going to be 6 over 5. So we know the value of y also. So the solution of these two equations is 19 over 5 and 6 over 5. This is how we solve a pair of linear equations by the method of elimination. Let's try this. Use the elimination method to find all possible solutions of the following pair of linear equations. 2x plus 3y equal to 8, 4x plus 6y equal to 7. Let us label the two equations as 1 and 2. In the elimination method, we have learned, first step, choose any one of the variables to be eliminated. So let us choose to eliminate the variable x. Now if we have to eliminate the variable x, then the coefficients have to be the same and the signs have to be opposite in both the equations. We know that the coefficients are not the same. So what will we do? In order to make it same, we will multiply the whole equation 1 by 2. But even if we multiply them, the signs are still the same. We need the signs to be opposite. So what we can do now, in order to make the signs opposite, we will multiply the first equation by -2. Now let's see what happens. Our first equation becomes 2 times -2 is -4. 3 times -2, -6y, equal to 8 times -2, -16. And our first equation remains the same. This is x, 4x. The second equation remains the same, 4x plus 6y equal to 7. Now add the two equations. -4x plus 4x cancels. Minus 6y plus 6y cancels. So we'll end up with 0 equal to -16 plus 7 is -9. And this is a false statement. 0 equal to -9 is a false equation. Therefore, we say that this pair of linear equations has no solution. Graphically, what does it mean? It means that the lines are parallel. Let's try this example. The ratio of incomes of two persons is 9:7, and the ratio of their expenditures is 4:3. If each of them manages to save 2,000 rupees per month, find their monthly incomes. So let's try this. We know that the incomes of these two people, let the income of the first person be rupees 9x, because it's in the form of a ratio, and the income of the second person be rupees 7x, and the expenditures of the first person be rupees 4y, and the expenditures of the second person be rupees 3y. Let us represent the incomes by x variable and the expenditures by the y variable. And now what are their savings? We know that savings is nothing but income minus expenditure is equal to the savings. So the first person's savings is nothing but his income 9x minus his expenditure 4y. His saving is 2,000 rupees. And the second person's income 7x minus 3y. His savings is 2,000 rupees. Find their monthly incomes. So let's try this. So now we have two equations over here. 9x minus 4y is equal to 2,000. And 7x minus 3y is equal to 2,000. We can solve this pair of linear equations by the method of elimination. And let's see how we go about. Let us label the first equation as 1 and the second equation as 2. Let us decide to eliminate the variable y. Now, in order to eliminate the variable y, the coefficients of y in both the equations have to be the same. In this case, as of now, they are not the same. So we have to make them same. How will we do that? We will multiply the first equation with the coefficient of y of the second equation, which is 3. And we will multiply the second equation with the coefficient of y of the first equation, which is 4. So in this way, the coefficients will become the same. But what about our signs? The signs are both negatives, but the signs have to be opposite to each other. So if one is negative, the other should be positive. Only then we will be able to cancel it out. In order to make the signs opposite, we will choose to multiply the second equation with -4. Now let's see what happens. Our first equation becomes 9x times 3 is going to be 27x minus 4 times 3 is 12y is equal to 2000 times 3, 6000. And our second equation now becomes 7x times -4 is -28x. -3y times -4 is plus 12y equal to 2000 times -4 is -8000. Now we add the two equations. So what 27x minus 28x is minus 1x. 12y minus 12y cancels, equal to 6000 minus 8000 minus 2000. Divide by -1, x is going to be equal to -2000 over -1, which is 2000. So now we know the value of x. We can plug it into any one of the equations, either equation 1 or equation 2, and find the value of y. Let us see what we get. Let's take the first equation and plug in the value of x. So we get 9 times x we know is 2000 minus 4y is equal to 2000. 9 times 2000, 18,000 minus 4y is equal to 2000. Minus 4y is going to be equal to 2000 minus 18,000. Negative 4y is going to be equal to 2000 minus 18,000 is minus 16,000. So y will be equal to minus 16,000 divided by -4, which is going to be 4,000. So we now know the value of y, which is 4,000, and the value of x, which is 2,000. The question asks us what are their incomes. The income of the first person is 9 times x. We know that x is 2000. So 9 times x, 9 times 2000, it's 18,000. And the second person's income was 7x. Remember, the ratio of incomes was 9:7. So 7 times 2000, which is 14,000 rupees. So the income of the first person was 18,000 rupees and the income of the second person is 14,000 rupees. Let's understand the concept of two-digit numbers. For example, let us take the number 56 at random. We are just choosing any number. Now we know that 5 is in the tens place and 6 is in the units place. The place value of 5 is 50 because 5 times 10 is 50 because it's in the tens place. And the value of 6 is 6 because it's in the ones place. So 6 times 1 is 6. When we add the two, it is 56. We know the concept. Now if we reverse the numbers, 56 becomes 65. Now this is in the tens place, 6 is in the tens place, and 5 is in the units place. Now the value of 6 is 60 because 6 times 10. And the value of 5 is 5 as it is 5 times 1. It's in the ones place. And the total value of that is 65. So I hope you have got this concept of two-digit numbers. Why did we do this? In order to solve the next problem. Look at this problem. The sum of a two-digit number and the number obtained by reversing the digits is 66. If the digits of the number differ by 2, find the number. How many such numbers are there? So let's apply the concept of two-digit numbers. Let the tens digit of the number be x and the units digit of the number be y. So we have a two-digit number over here. And we know that the value of x, that's going to be 10x. Plus the value of y is y. So this is going to be the first number. Now when we reverse the number, the digits become yx. So the value of y now is going to be 10y. And the value of x is going to be x. The question says the sum of the two-digit number and the number obtained by reversing the digits. This is the sum of the two-digit number and this is the sum of the two-digit number after reversing it. And it says that the sum of these two numbers is 66. We can open the brackets and simplify it. So 10x plus x will make it as 11x. 10y plus y is 11y is going to be equal to 66. We can remove the 11 out as a common factor. So x plus y is equal to 66. X plus y is going to be equal to 66 divided by 11, which is going to be 6. So we have our first equation, x plus y is equal to 6. Let's label this as equation 1. The question reads further. If the digits of the number differ by 2, now we can have two possibilities. The first possibility is x minus y. The digits are differing, x minus y, by 2. Let's take this as equation number 2. Another possibility could be y minus x, with y being greater, equal to 2. Let us take this as equation 3. So now either it can be x minus y be equal to 2 or y minus x be equal to 2. What we can do is we can take the first two equations, solve them by the method of elimination, which you are already familiar with, and get the value of x and the y. Or we can take the first and the third equation for the second case, solve these two equations by the method of elimination, and then get the value of x and y. I leave it upon you, and I'm sure you will be able to do it because you have understood the concept of elimination by now. So try these two sets of equations, find the values of the numbers. If you take equation 1 and 2, and if you solve them, you will get x as 4 and y as 2. So the number is 42. If you take the first equation x plus y equal to 6, and the equation 3 x minus y minus x equal to 2, equation 1 and 3, and then if you solve it you will get x as 2 and y as 4. So the number will be in this case 24. So we have two such numbers, 42 and 24. Good luck to solve. Try it out and I'm sure you will be able to get the right answers. Let's try this. Meena went to a bank to withdraw 2000 rupees. She asked the cashier to give her 50 rupees and 100 rupees notes only. Meena got 25 notes in all. Find how many notes of 50 rupees and 100 rupees she received. So let the number of 50 rupees notes be equal to x and the number of 100 rupees notes she gets be equal to y. In total, the number of notes she got was 25. So x plus y will be equal to 25. The value of the notes, if x is the number of 50 rupee notes, so the values of 50 rupee notes will be 50x and the value of the 100 rupee notes will be 100y. Together the value of the amount was 2000 rupees. And we know that the total number of notes she got, x plus y, is 25 rupees. So these are the two equations we have, equation 1 and equation 2, and we can solve them by the method of elimination. Good luck, go ahead, give it a try, and I'm sure you will be able to solve it and get the right answer. Do you know what is the right answer? The number of 50 rupees notes will be 10 and the number of 100 rupees notes will be 15. You can even verify this answer. Great job. A lending library has a fixed charge for the first 3 days and an additional charge for each day thereafter. Sarita paid 27 rupees for a book kept for 7 days, while Susie paid 21 rupees for the book she kept for 5 days. Find the fixed charge and the charge for each extra day. So let's give a try. Let the fixed charge for the first 3 days be x rupees and the additional charge for each extra day be y rupees. So the first part of the problem says Sarita paid 27 rupees for a book kept for 7 days. Now in those 7 days for Sarita, 3 days charge, which is x, and she has kept the book for 4 extra days. So for each day the charge is y. So if she has kept the book for 4 more days, it's going to be 4y. And the total charge she paid was 27 rupees. Now the second part of the question says, while Susie paid 21 rupees for the book she kept for 5 days. So out of those 5 days, 3 days have a fixed charge and she kept for 2 extra days. So 2y. And together she paid a total of 21 rupees. Now this forms a pair of linear equations with this is equation 1, this is equation 2. We can solve them by the method of elimination. Good luck. And when you do it, which I know you will do it right, the values of x and y will be, so fixed charge will be 15 rupees and the additional per day charge, that is the value of y, that is going to be 3 rupees. You can of course plug it in place of x and y in the equations and verify your answer. Great going. I really appreciate the efforts that you have put into understanding this lesson. I hope the explanation was clear enough for you to solve more problems on your own. Join me in the mission, helping you learn. Share and subscribe to this channel, Wisdom Outlined. Thank you.